Hello, this is Mr. Stansbury. I'm going to take you through the 6G notes on linear simultaneous equations. So, linear simultaneous equations is secret code for a system of equations, or two equations with two unknowns. So, or at least in this case, it's two equations, two unknowns. So, at the end of this, you should be able to solve a system of equations by either substitution or elimination. Okay? So, let's jump straight into the example so I can show you what we're talking about here. Solve simultaneously by substitution. So again, this should look hopefully familiar from algebra, maybe a little bit of geometry, but it's just this is called, you're probably used to hearing this called systems of equations. Okay, so what we're going to do is we're going to go through and figure out what x and y are for each one of these. So substitution, if you'll remember, is where you take one thing out and you substitute something in its place. Right? So like if I wasn't at school, then a substitute teacher would come in to make sure that you didn't burn the place down. So that's kind of the same type of idea here. So what you want to do, we have y equals 9 minus x. So wherever we see y in this other equation right here, then wherever we see that y, we know that we can plug 9 minus x into that spot for that y, right? So that's exactly what we're going to do. So we have 2x plus 3, and now we know that y is 9 minus x. And then this all equals 21. Now, think about what the advantage of that would be. Okay, so take a second, think about it. Hopefully you figured out that the advantage now is instead of having x's and y's, look, now we only have x's. So now we can solve for x. And then once we figure out what x is, we can use one of these two equations to figure out what the y is. Okay, so let's distribute this 3 through to both of these, and then we'll solve it. So we have 2x plus 3 times 9 is 27 minus 3x equals 21. Right? So collecting like terms, we have 2x minus 3x gives us negative x plus 27 equals 21. So we add, oops, not going to add, we're going to subtract 27 from both sides. And we get negative x equals negative 6. So if negative x equals negative 6, then positive x is going to equal positive 6. Okay? So, solving simultaneously means we have to figure out what x and y is. We figured out what x is, now we got to figure out what y is. Okay? So, you can plug it into either one to solve for y. I would highly suggest using this one here because look, it already says y equals. This is a much easier formula to use, so I'm going to use that one. So y equals 9 minus x. Again, now we know that this x here is 6. We can go y equals 9 minus 6. So now we know that y equals 3. Okay. So we usually write our solution like this. We write always go alphabetical, so x goes first, y goes second, and we write it as an ordered pair. Okay, so there's our answer. Okay, and it's always wise to double check to make sure that it works. So let's plug our 6 and 3 back in to make sure that it works. So let's do a check. So y, which is 3, so 3 should equal 9 minus 6. 3 equals 3, so that one works. Let's double check to make sure that it works in the other one also. 2 times x, which in this case is 6, plus 3 times y, which is 3, should equal 21. So that's 12 plus 9, and 12 plus 9 does in fact equal 21. So now you know you have this one right because we double checked it. Okay, so that's solving by substitution. Another way that they like to have us do things, and honestly this is often in life, this is the easier way to do it, is solve by elimination. And then some people have heard it as linear combination. There's some other names too, but elimination is what you're trying to do with this is you're trying to eliminate, get rid of one of the variables. Okay, so we could either get rid of the x's or you can get rid of the y's, and it doesn't really matter which one you do. If you're looking at e's, it does matter which one you do. On this one here, what we're going to do is we're going to add the two lines together to try to get rid of one of the variables. So what that means, so to solve by elimination, you need to have one set of the variables have to be opposites. So look, 3y and negative 3y are opposites. So to solve by elimination, you need to have one set of variables to be opposites. Right? So for example, 2x and negative 2x, 13y and negative 13y. Those would be opposites. That's what you need to have. So again, this works out really kind of nice because look, these are already opposites. So all you have to do on this is just add these lines together. So you go 4x plus x gives us 5x. And here's the key. 3y minus 3y gives you 0y, so those cancel out, and that's the whole point of elimination. And then you go 2 plus 8 gives us 10, because again, now look, we only have one variable, so now we can solve for that variable. Divide both sides by 5, and we get x equals 2. Now that we know x equals 2, we got to figure out what y is, so we can plug it into either formula. I'm going to plug it into this top one just because I like it when my variables are positive, so I'm going to do that. You can plug it into this one too, and it should work out. It will work out fine as well, as long as you do your math. So 4 times 2, so again I'm using this formula here, 4 times 2 plus 3y equals 2. So 8 plus 3y equals 2. Subtract 8 from both sides, and we get 3y equals negative 6, right? And then we divide both sides by 3 to get y equals negative 2. Okay? So let us double check to make sure that we have the right answer. So let's check it. And we'll plug those in because again our answer ended up being 2 and negative 2. Okay, so 4 times x, which in this case is 2, plus 3 times y, which is negative 2, equals 2 is one of them, so that's 8, negative 3, sorry, 3 times negative 2 is negative 6, equals 2. 8 minus 6 is 2. So that one works. And then let's do the other one, x, which is 2, minus 3 times y, which is negative 2, equals 8. Negative 3 times negative 2 is positive 6. So we get 8 equals 8. And so that one works. So then we know we have the right answer. All right? Okay, let's look at one last example, and then off we go. Okay, so this is example 23 from page 185, and this says solve simultaneously by elimination. And really, if you decide that you want to do, it says solve by elimination, you want to do substitution, then go ahead, and vice versa. If it says solve by substitution, you want to do elimination, that's fine. I'm not gonna care which way you do it, as long whatever way works for you. Okay. On this one, we want to try to get opposite variables. So those 3 and 2 are not opposites. 2 and negative 5 are not opposites. The signs are opposite, but the numbers are not opposites. So we need to multiply one or both lines so that we get the exact opposite variables on one of these. And again, it doesn't matter which one you do. You can do it with either x or y. I'm going to elect to do it with the y's because, again, I already have a positive and a negative. So then I can just multiply both by positive numbers. So what we got to do is we got to figure out what 2 and 5 both have a common multiple of. Right? So if you think about it, if you multiply this way will always work. You can always multiply this line up here by that number, so 5, and multiply this line down here by this number. Sometimes you don't need to even do that. Sometimes you can just multiply one line or the other. But if you think about it, if I multiply 5 times 2, that's going to get me 10y. And if I multiply 2 times negative 5, that's going to get me negative 10y. So then my variables will be opposite. So then I know I'm in good shape. So I'm going to distribute this 5 through and then see where we end up. 5 times 3x is 15x. 5 times 2y is 10y. 5 times 7 is 35. And then this one here, 2 times 2x is 4x. 2 times negative 5y is negative 10y. And then 2 times 11 is 22. Okay? And then again, the big key in here is this. This is what we were trying to achieve. We're trying to get opposite variables. Right? So now that we have that, we can just add these up. 15x and 4x is 19x. These cancel out. 35 and 22 is 57. Right? So we divide both sides by 19. And we get x equals, let's figure that out. So we're going to do 57. 57 divided by 19 gives us 3. Okay. Now that we figured out what x is, we're going to go back and figure out what y is. Again, you can plug it into either formula. It will work just fine. I'm going to choose this one up here because the y is positive, and it just makes it a little bit easier for me. So 3 times x, which we now know is 3, plus 2y equals 7. So again, this came from here. So that's 9 plus 2y equals 7. Subtract 9 from both sides. And that goes away. We get 2y equals negative 2. Divide both sides by 2 and we get y equals negative 1. So we've got x equals 3 and y equals negative 1. So let's double check to make sure that it works. Okay, so 3 times the x, which is 3, plus 2 times the y, which is negative 1, should equal 7. 9 minus 2 equals 7, that's true. And then we also have 2 times x, which is 3, minus 5 times y, which is negative 1, should give us 11. 2 times 3 is 6. Negative 5 times negative 1 is positive 5. 6 plus 5 is 11. So we know that that works as well. Okay? So now we're all finished. So you should be able to solve a system of equations by either substitution or elimination. And again, you can use whichever way works best for you. Okay? Thanks. If you have any questions, feel free to ask.